Welcome to today's webinar, Amazon Aurora for the Enterprise, Lower Cost, Better Performance. Our presenter today is Scott Ward. Scott is a solutions architect with Amazon Web Services. Based out of Seattle, Washington, Scott is part of a team that supports AWS's global network of technology and consulting partners. Our moderators today are Abdul Said and Rory Richardson. They will be answering your questions as they come in and engaging with you while Scott presents. Scott, welcome. The floor is now yours.
Excellent. Thank you very much, and good morning, everybody. Hello, my name is Scott Ward. I am your solution architect for the day, and thank you everybody out in webinar land for taking the time out of your day to join us and come and talk and learn about Aurora here. Fun fact about me, I've been with Amazon or Amazon Web Services for the past 15 years. I spent my first 13 years working in financial systems, so working on a platform that was very much dependent upon a relational database. And so the whole concept of Aurora and what it can deliver is very intriguing to me based on some of the work that I've done and some of the challenges I've had to overcome in the past. Taking a quick look at some of the poll questions, it's very interesting. First of all, thank you for taking the time to answer the poll questions as you waited. We've got a good mix of answers that we've come through as far as things that might interest you about Aurora around managed databases, performance, reliability, and availability, and scalability and cost. We're going to be touching base on all of those items today throughout our webinar. As far as database engines you primarily work with, we've got definitely MySQL's at the top, but we've got a nice mix of Postgres, SQL Server, and Oracle in there as well. And we'll be talking about some of the options you might have if you're running those database engines today. As far as what you'd like to do next with Aurora, there's some things around starting to use it immediately. We'll talk about how easy it is to use Aurora, proof of concepts or test workloads. We'll talk a little bit about how you can maybe do some proof of concepts as far as understanding the performance and what Aurora can do for you. White papers and learning more will give you some guides on some things that you can actually go where you can go and learn a little bit more about Aurora. As far as helping you on the journey, certainly providing more educational material. We're going to part of the intention of this webinar is to help you with that today, and then we'll give you some more items as far as where you can go and look for more material as it relates to Aurora in general. So what we're going to be doing today is we're going to focus on Aurora and how it can fit into the enterprise landscape and some of the characteristics that exist in Aurora and that can really help you achieve the needs that enterprises often have when it comes to running their databases. So let's go ahead and get started here. So when it comes to running a database in an enterprise organization, there's often pretty strict requirements that can't be compromised on. They often have a need to ensure that the database can perform some high-scale operations or be able to scale when needed and pass the security requirements that are often related to internal and external controls. In my experience, these items are often a necessity, but they're not simply easy to do. It's a lot easier said than done, and they require a lot of time and effort and money to actually implement. Additionally, it's not usually just one database that needs to exhibit these characteristics, but it's usually many databases throughout the organization, so there's lots of people and lots of different teams that often get involved in working on this. So when enterprises are at the same time are looking at managed services, they're looking for something that's going to give them productivity benefits and cost savings while allowing them to actually retire a lot of the operational burden that came with their traditional infrastructure-based solutions. So when you take these two items and you look at what's needed, out comes a need for kind of a fully managed enterprise-class database service without that cost and complexity that might exist with a traditional or current database software. So when we look at traditional relational databases are still very important. They still have their place in the enterprise, in the startup, in the public sector. Relational databases have been around for about the 70s. They serve a good purpose. They have a lot of good things that they can still do today. I significantly relied on them in my role at financial systems. We were very much dependent upon the database and being able to meet our needs. The problem with that design of a lot of these databases, it really hasn't changed significantly in the time since they've created, and they haven't really kind of adopted to keep up with some of the technologies and concepts that exist today, especially when you look at cloud computing. The engine for these databases was designed to run on a single mainframe server, and when you needed to get more processing power, you just got a bigger box. You scaled vertically, and at some point, just going to a bigger box wasn't enough because either the box couldn't get any bigger or you needed more. So over the years, there's been some gradual improvements to do things like implementing some different scaling and availability solutions like sharding or shared storage, but they all still involve running this one single monolithic stack at the end, where the SQL, the transaction, the caching, and the logging are all kind of grouped together and clumped together. So the core of the database engine really it hasn't really evolved a lot over time. And along the ways, there's also some other challenges that you typically start running into with this approach, that you've got to get the infrastructure supporting your database engine and potentially the separate infrastructure that's supporting your storage, talking and working well together, as well as investing in all the operational resources and time that goes with making sure that they continue to stay up and work well. And at times, to get optimal performance out of that database engine, there's exercises you had to go through in order to tune the parameters, test load against the database, make sure those parameters are right, and make sure you're actually getting the performance you're looking for out of those. So overall, a highly challenging effort to really get your database performing at the level that you need to. So a few years back at AWS, we took a step back and we asked ourselves, how would you reimagine the relational database? Knowing what you know now with cloud-based technologies and concepts and the AWS services that are available today, what could you do to still enable somebody to have a relational database but significantly reinvent it? So with that, we arrived at what is now Amazon Aurora, which is a MySQL compatible database engine. So if you're using MySQL today, there's a good chance that you can also run Aurora. But if you're not running MySQL, we still have good paths for moving to using Aurora, which we're actually going to touch base on later on in this webinar. So Aurora is purpose-built for the cloud. You may have seen some of these kind of overviews of Aurora and some of the videos prior to the webinar. We leverage a lot of the existing AWS services and technology that our customers are also using today in order to really create the architecture that is an Aurora database. The architecture is a service-oriented architecture, multi-tier. It's distributed, allowing for very high availability and redundancy. Has the ability to scale support for different components and really based on the demands that are being placed on it. We've moved that logging and the storage layer that was in that monolithic stack. They're actually moved out into their own multi-tenant scale-out database storage. And the SQL and the transaction layers, which are still part of the database, but they're into their own layer as well. And then we've taken that caching layer that's part of the database engine. We've moved that into its own layer so that it can be able to scale and run independently of the storage and the database and the transaction layer. We've also integrated with some key services such as S3 to enable us to really have continuous backup and take advantage of the durability and scalability that comes with that service, as well as integrating with other AWS services to really take advantage of the cloud and what those services can offer. So with this architecture, the components at every layer are also self-healing and are designed for resilience, meaning that if there's a failure with one component, the service takes over and fixes the failure with little or no downtime, as well as it is able to continue to run while that component is being repaired. And finally, we've architected a solution for security and performance so that you can live up to those enterprise requirements that we talked about a few slides ago. So all of this is intended to really deliver you the enterprise level database experience that you need, but not maybe at that enterprise price and with some of the operational burden that you might normally expect when you're standing up your database. So at AWS, security is a top priority for us, as it is with many of our customers. And being able to secure their database environment is very important for our customers. And there's lots of features that exist within Aurora that actually allow you to achieve the security profile you're ultimately looking for at the database layer. One of the key ones is around being able to isolate your data and control access to your database. And one of the key ways that we enable that at AWS is with the virtual private cloud, or the VPC. With the VPC, you're able to define your own private address space inside the AWS cloud. So you get to pick what your networking looks like. It's creating your own little private data center. You get to create subnets within that overall virtual private cloud. You can make them public or private. Public meaning they have access to the internet, private meaning they don't. Around your database itself, part of a VPC features, you actually get to define security groups for your database. These are actually like a virtual firewall around your database that will dictate what kinds of traffic can come in, what kinds of traffic come out of the database. And you can define that at the down to the level of which IP addresses or collection of IP addresses, which port, which type of network protocol is allowed into your database. And then finally, you can actually connect that virtual private cloud, and you can extend it to your corporate data center or your corporate offices using a virtual VPN or an IPsec tunnel, or even using AWS Direct Connect if you need more of a high-speed, consistent throughput between your corporate location and your AWS region. So kind of full control over your network as far as where your database lives and what can access it and what your database can interact with. Key security feature. Another key security feature that we often see, and at times this is both related to internal and external requirements placed on the enterprise, are really being able to encrypt the data at rest and at transit. So The encryption at rest is using our key management service. So it's a managed service that takes care of the scalability, reliability, durability, security, the key deletion, key creation, and even key rotation that goes along with what you might find from a normal key store service. So this allows you to really be able to focus on running and using your database and not having to worry about all the other infrastructure and the operations that go with a key store. So key management service allows you to encrypt your data at rest running on Aurora, and that's not only just encrypting the actual data store, but it's encrypting all of your automated backups, all of your snapshots of your database, and any read replicas that you make in an Aurora cluster are all also automatically encrypted with the same key that you're using in key management service. Key thing on that key management service is that for every Aurora or database instance you create, key management service will actually vend up a separate data key for each database instance. So each database instance will be running with its own encryption key. This encryption is seamless, so you're going to see no changes to your application. You should see no performance hits. The service will take care of encrypting and decrypting the data as it's reading it and delivering it back to you in your database queries. Another key thing that Aurora offers is SSL encryption. So some compliance organizations, such as HIPAA, require that your database be encrypted while it's in transit. And SSL is there to be able to actually allow you to encrypt your data as it moves to and from your database between your applications to give you that full encryption and knowing that your data is protected while it's in transit. When it comes to the enterprise, there's also an expectation that the database supporting the enterprise is actually able to deliver a high level of performance to be able to support the large and growing needs of an enterprise company. There's often a need to work on a lot of data and be able to get it done quickly. So let's take a look at some of those performance characteristics that exist in Aurora and how that might help with the ability to achieve performance that's expected out of the enterprise segment. First one we have here is a test that we did around what can Aurora do in supporting write. What kind of throughput can it deliver when it comes to write performance? So what we did is we ran a test. We used the MySQL sysbench test, which is kind of the de facto standard for kind of benchmarking a MySQL database. Remember, Aurora is a MySQL compliant database. We created 4 client nodes using R3 8 extra large EC2 instances, and those have 32 cores of CPU and 244 gigs of RAM. We did some changes to the kernel parameters to optimize throughput. We turned on enhanced networking, and then we had each of these client machines running 1,000 threads each and doing writes into Aurora. So we measured that write performance over 30 minutes. We were able to get about 107,000 writes per second over the life of that test. And then we went and did a test at read performance as far as what Aurora can handle when it comes to reads. And so we did a similar thing. We actually used just one client machine doing 1,000 threads of reads against the Aurora database for those 30 minutes, and we were able to achieve about 585,000 reads per second over the life of that. So a pretty high scaling database, handling a lot of threads and delivering a lot of performance initially from these tests that we're showing you here. Okay. Additionally, we've had some independent looks at Aurora. The people at Info and looked at some of the things that we produced on Aurora, and they went and they did their own tests. They actually wanted to verify some of the results that we just saw and make sure that they could have them themselves. And so they actually went in and created the same testing mechanism that we did and did their own tests against Aurora to see what it got. You can actually go and look at those on the Aurora product page and read this article to kind of see what they got. The key thing here is that they were able to reproduce this performance test, and you can also go do that on your own. We've actually made an entire white paper available. If you actually just search for Aurora performance white paper in any search browser, you'll be able to actually get a copy of that white paper yourself, get the details on how we actually created that environment and were able to execute those tests. And you can go and execute those tests yourselves, or maybe even implement some changes in those tests to test some different use cases that you might find interesting for your particular organization. So in addition to the basic read and write tests that we just performed and talked about here, some of the additional tests that we did on Aurora, these might help better replicate what a typical use case might look for a company. You know, at a company, you're not just doing reads and writes all the time independently. You've got concurrency. Things don't necessarily fit into your dictionary cache or your data cache. So there's some different use cases that we want to be able to test for. So one of the tests that we did against Aurora was how to writes scale as the number of tables grow, and you potentially become to a point where not all of the data dictionary can actually fit into the data dictionary cache. So we scaled from 10 to 10,000 tables throughout the life of this test using an Aurora database cluster, as well as several different MySQL clusters. And you can see over time, the Aurora database was able to keep up pretty consistent write throughputs against those tables up to 1,000. It went down a little bit, about 10,000. But the interesting thing here is that all the Aurora, the various MySQL ones, either using local drives, local memory, or attached storage with very high provision throughput, had difficulty keeping up with that. And it's not even just that things went down for different configurations. You can see that the general write throughput in general is consistent across all the MySQL ones. So that's not necessarily a problem with the storage, but might be a little bit more of a problem with the actual database engine that's running for those particular configurations. Now, one of the things that we looked at was really how to write scale with the number of connections. And this is a really interesting one because we scaled up the number of connections from 50 to 500 to 5,000 over our tests. And you can actually see that the Aurora database got faster. It was actually able to handle more writes as it got more and more connections, which is a pretty interesting thing. You don't normally expect that a database is actually going to get faster or be able to do more work as it gets more connections to it. You expect normally that that's going to overload your resources and actually make things a little bit slower. So we did these tests using the sysbench OLTP workload, which gives you some contention as far as various things, trying to get at the same data in a table or try to contend and get the same information out. And we'll talk about what actually allows us to do this, but the key thing here is that Aurora actually enjoys it and likes to get faster as it gets more and more connections versus what you see on a typical maybe MySQL database, where over time the number of connections is actually going to cause the database to get slower and slower. So how do we do this? We actually are able to do this a couple different ways. One is that we do less work. So we use less IOs. If we're doing less IOs, then we're moving less data around the network and we're dealing with less disk access. This allows us to be a little bit more tolerant when it comes to network latency, and because we're moving not as much data through the environment, we're able to do more or be able to batch things up and be able to tolerate any of the latency that might exist. We have more of some pretty effective query caching. So as I mentioned before, we've moved that querying layer into its own separate scalable layer, so it can be a little bit more flexible in how it caches data and how it scales up to handle caching. We have the read replica management, so we're able to effectively distribute data from our master database to read replica databases, once again resulting in very little network traffic, enabling that read replica to actually be nearly 100% read focused as well. And we do this pretty efficiently. So we have the latch-free lock management. This allows us to remove some of the serialization constraints that you might normally happen with traditional locking and latching approaches in a relational database. We have these adaptive thread pools that allow us to really scale up and down the number of thread resources needed to handle client connections coming into the database, and it really helps us support a large number of concurrent client connections. And then we do asynchronous commits. This allows us to start doing I/O work on each commit as it comes into the database, allowing Aurora to be a little bit more efficiently be able to do its work with each connection, not have to wait for buffers to fill up before actually acknowledging a commit back to its clients. So here's a little bit deeper dive in one of the examples of doing more with less. It's really focused around I/O. So on the left-hand side of the slide, we have a MySQL database running an RDS with a standby instance. And so when you have a write happen, that write's going to happen against that primary database. It's going to be written to the attached Elastic Block storage. It's going to be mirrored to Elastic Block Store Mirror, which is part of the normal EBS service. You get that for free. And then it's going to be, that write's going to then be pushed to the standby instance. And it's once again going to be written to the block storage and mirrored to the additional EBS storage that exists in that availability zone. So that whole process, the write in the primary instance, the movement to the standby, and the write in the standby, that's all synchronous. That all has to happen for the transaction to be complete. And so that's a lot of data moving around. And over time, that can become really impacted when it comes to things around network latency or network weather. So And in addition to that, you also have lots of log files that actually have to move around within the database as well. And the movement of those log files, once again, around the primary instance and the standby instance, can really be impacted if you have any sort of network interruption happening within your overall environment as it relates to these databases. So with this configuration, we actually did some tests. We wanted to see how we could compare what was running on this MySQL configuration versus Aurora. So we ran the sysbench write-only workload test with a 100 gigabyte data set for 30 minutes against a single MySQL configuration with 3,000 IOPS provisioned. And then over that time, we actually were able to get through about 780,000 transactions of writes in that 30 minutes. And over that time, we saw that it took about 7.4 million IOs that actually occurred to be able to support those 780,000 transactions. So about 7.4 IOs happen per transaction. Not too bad for the database. Now on the Aurora side, we do things a little bit differently. You can see on the right-hand side, we have an Aurora cluster. We have the primary database instance, and that's then connected to the storage layer. This is a multi-tenant storage layer that covers covers 3 availability zones. It's got 6 storage nodes. One of the key things here is that when a write happens on the primary database instance, we then send data to the storage nodes, but it's only read log files. These are very small log files that represent the transactions that have happened on the database. And so there's very little data that's actually moving across the network. On top of that, we actually batch these log files up and send them in batch to the storage nodes. So even though there are 6 times more writes happening, because the writes has to happen against all 6 of the storage nodes, there's actually 9 times less network traffic happening in this configuration versus the MySQL configuration. So we did that same sysbench write test as we did on the MySQL database side, and we found that we were able to actually get through about 27 million transactions in that 30-minute time frame, which is about 35 times more than on the MySQL side. Came out to about 158,000 I/O operations per storage node. So you want to add 6 to that total, multiply that by 6 to get the full coverage. But it helps to represent that by doing more, we can do more by doing less, because we're not pushing as much data across the network, and these are very small log files. It's much more tolerant of any sort of network latency that happens, and so it allows us to do more with less through this approach of moving less data around the overall network. So having a high availability database is an important part of your overall application architecture. If the rest of your application is highly available and your database is not, then you're still going to have application downtime at the end of the day. There are things that are part of the overall Aurora architecture that are there to help ensure that your database will be running in a very highly available configuration. So to start with, let's talk about the Aurora storage. So I mentioned briefly the configuration. It's highly available by default. So it has 6 storage nodes running across 3 availability zones. So we're replicating that data across all 6 of the storage nodes. So at the end of the day, they're all expected to have the same data. When we do a write, we need a response from 4 of the 6 storage nodes to acknowledge that a write is successful. And when we do a read, we need an acknowledgement from 3 of the 6 storage nodes to confirm that that read is available. And so that does a couple things for us. One, it helps to ensure that we're always getting a response from the fastest storage nodes when it comes to latency, so that we're giving you reads and writes as fast as possible. But what it also means is that the overall storage layer is able to survive some pretty big events. So it can survive the loss of an entire availability zone and still be able to do and serve reads and writes successfully, but can also survive the loss of 2 storage nodes within that storage tier and still be able to serve reads and writes successfully. So it's got a very highly available configuration built into it. The storage layer itself is built based on SSDs. It's a multi-tenant scale-out type architecture. So the database, your storage can grow up to 64 terabytes in size. You only pay for what you use. You don't actually provision any storage. When you launch an Aurora cluster, we will naturally, as part of the managed service, grow the data storage as you start writing and reading more data. And because I mentioned before, we use that log structured storage. So we're using very small redo logs to move data around that network and be able to support your database at very high scale. It helps to eliminate a lot of the chatter between the database and the storage layer, because the database is all it's doing is it's sending and receiving these small redo log files in there. So when we look at that configuration, we have we mentioned before, it's very self-healing and fault-tolerant. So here's a representation, once again, is that you can lose an entire availability zone and your Aurora cluster will still be able to do reads and writes successfully. You can lose multiple storage nodes and your database can still be able to support reads and writes. Because it's a managed service, there's automatic detection, replication, and repair. So one is the actual Aurora operations team keeping an eye on things to make sure that the system is performing well. But that storage node also has some self-healing built into it. There's actually a peer-to-peer gossip network that exists among all 6 of those storage nodes, and they will talk to each other. If somebody's missing some data or if a data block has become corrupt, they will actually talk to the other storage nodes to say who's got a good piece of this data, so that they can actually exchange that data and make sure that all the storage nodes are caught up with the most recent data. When it comes to backups, there's something, it has to be done. It's a necessary part of being able to run your database. You know, you need to be able to give yourself coverage in order to be able to restore your database, be able to react to any data corruption or unexpected events that might happen with your database. So traditionally, there's been a lot of different approaches of how databases can be backed up and what your backup strategy can be. You can have hot backups or cold backups. Those are both options. Depending on the company and your system requirements, your backups can be scheduled to happen at regular intervals, things like 6 hours, 12 hours, once a day. Some companies take incremental every day and then do a full backup every Sunday. There's lots of different backup approaches that people take, and they have lots of questions that need to be answered. Do I do a cold backup, which actually requires the database to be down or paused, or do I do a hot backup, which should actually cause performance problems on the database, depending on the time of the day? Then you have questions on where you're going to store the backups, which types of storage media am I going to use, and then how do I know that the backups are actually preserved, and finally when the time comes to actually restore my data, how do I actually find the right backup that relates to that point in time that I want to restore to? How do I find additional infrastructure that I can actually restore to so that I can recover and examine my database? So overall, there's lots of operational challenges that go along with backups related to a database, but they're a necessary part of being able to run a database. So with Aurora, this is where some of the managed service stuff kicks in. This has all been taken care of, and it's one of the benefits of the managed service. So Aurora does continuous backups to S3. I mentioned that earlier. You get the durability and availability that comes along with the S3 service. And these backups are happening from the storage layer continuously in S3. So there's no need for you to monitor them. They're taken care of by the managed service. And they also exhibit no performance impact on your database because they're coming from the storage layer. And as we remember from our slides earlier, the database is just sending small redo log files to the storage layer, and that's its only interaction with that storage layer. So backups can happen very frequently without any impact on the performance of your overall database. And with S3, because it is so reliable and durable, we actually consider our database to be persistent once that database actually gets into S3 to be able to support your backups and recovery of your database. Now, databases crash from time to time. It's inevitable. They go down, they have problems, and there's a need to recover it and get your database back up and running when that happens. So in a traditional database world, when a database crashes, you get the database back up, and then you need to find your last checkpoint of the data. What's the last known good point of data that you might have? And then starting from that checkpoint, you actually need to replay all the redo log files that have been acquired since that last known checkpoint of data. When it comes to MySQL, that's actually a single-threaded process that can only run on one CPU. So even if you have multiple cores, you can only take advantage of one. But at the same time, if you had multiple cores supporting reads and writes of your data, you may actually have a lot of data that's been acquired that needs to now be replayed in order to get yourself caught up. So you have a variable amount of time that it may take, depending on how much data was coming into your system at the point you had a crash, before you can actually get your database back up and running in a traditional database model. If you look at Aurora, we talked about that log-structured storage system that's under the covers. So when Aurora wants to get a data block back out of the Aurora storage, it goes and tells the storage layer, hey, I need this piece of data. The storage layer is going to go get that block of data and look at it and see if there's any newer redo log files for that block of data that maybe have, that the block of data doesn't have. If it is, it will actually apply those changes to the block of data and hand it back to the Aurora database layer. The thing is that that's what happens during normal operations, and that's also what happens during instance crash recovery. And it happens in a parallel distributed and asynchronous process. So because the database is able to get real instantaneous delivery of the data, there's no need for when an instance recovers, it's instantaneous, nearly instantaneous on Aurora. There's no need to replay log files or wait for that process to happen in order to be able to get back up and running. You're able to get back up and running and start reading and retrieving your data right away when you have an instance crash recovery on Aurora. Here's another kind of timeline example when it comes to failover and recovery. At the top line, we look at MySQL. We have a database failure happening. We have a amount of time taken for the actual failure detection. And the recovery process, the part that we talked about earlier, takes a variable amount of time. We don't know how long it's going to take because the amount of data coming in, how much we actually had to replay from the checkpoint is unknown. It could take a different amount of time depending on the time of day. On top of that, you also have DNS propagation with the RDS service. So it's going to flip your DNS name over to the new database node that's supporting your database. And that can take 30 to 60 seconds before you're actually able to even begin to connect to the new database. So overall, it results in kind of a variable amount of time before your application can actually get up and running for your failover. So it's not very easy to predict how long your app can be up when you have a failure. With Aurora, we still have the database failure happening. Failure detection from the managed service is roughly running in the range of about 15 to 20 seconds now. And then that recovery point, the part where I talked about where a database node can be up and running and reading data very quickly, is running in the 3 to 20 second time frame. And then your application is actually able to get up and running. Now, we talked about the DNS propagation, and that could still exist on Aurora, but you're actually able to work around that. And our team's been working with the team over at MariaDB to actually create a driver for Aurora. And we're using this driver as part of your applications. You're actually able to bypass the DNS part entirely. This driver is aware of which instance in your Aurora cluster is your master database at any point in time. There's actually a table in all the databases that make up your Aurora cluster that holds what's the IP address of the master database. And this client is aware of that. So as a recovery happens on a new database instance node, the managed service will update that table with what the IP address of the current master database is, and the MariaDB client will use that to be able to connect to the proper database at all times, avoiding any sort of DNS propagation that you may have to deal with when you're trying to recover your application. So you'd be able to get a much more predictable and fast recovery when it comes to running with Aurora in combination with this particular driver. So these things I've talked about as far as how the system can flex and recover when there's failures, it's often difficult to be able to actually test those in a real-world scenario. What we've done on the Aurora side is we've actually built SQL commands into the Aurora database that you can actually run yourself to be able to simulate the failure of a component at the database node layer, to simulate the failure of disks, to simulate some network problems or failure of networking, or to simulate the failure of an Aurora read replica. So you can actually be running tests on your Aurora cluster and actually make these events happen to see how your applications react and see how the Aurora service handles when these situations actually occur. So one of the key things about the Aurora database is that it's an engine choice in the relational database service, or RDS. This means that you're getting the benefit of someone else who's taking care of a lot of the under the covers, undifferentiated heavy lifting that might go with running a database. So someone else is taking care of the monitoring and the maintenance at the infrastructure level while you're taking care of actually just using the actual database for your application. So in this presentation, we've already outlined some of the challenges that go along with managing your own database. There's a lot of operational and planning resources required to get a well-performing database up and running, as well as keep it running well. This slide illustrates some of those areas that you might be investing your time in when it comes to running and managing your own database. And you can see a lot of time is spent on kind of operational things, and that scripting and coding is actually, you don't have a lot of time to work on your application, or maybe you're not spending as much time on your application as you want to because you're managing your actual database. So when you look at the RDS platform, which is providing the Aurora engine, you're able to remove a lot of the things that you might normally deal with and arrive at a point where managing your database is a lot easier. So on the RDS side, it takes care of the backup and recovery, the isolation and the security, any industry compliance that may be needed. It helps you with the push button scaling, where you can just, with a few clicks of a button, be able to scale up or scale down your database. It takes care of the patching for you as the managed service. It gives you advanced monitoring. It takes care of a lot of the routine maintenance that might normally go along with a database engine. It allows you on the left-hand side to really be able to focus on the things that matter most and are going to help you differentiate your application and your business, focusing on your schema design of your database, focusing on how you're going to write your queries and what they look like, and focusing on how you can optimize your queries. How can you best tune your queries to be able to run in your database for the type of data you have and the amount of transactions you're ultimately dealing with. One of the cool things that's come out recently for Aurora is advanced monitoring. So as a managed service, you don't have access to the host operating system that Aurora is running on or any database in RDS, but there's often metrics that somebody who's really wanting to monitor and understand their database need to get at that are often available at the operating system level of the database. So we've helped solve that problem with advanced monitoring, where we are delivering some very fine-grained metrics. You choose a granularity from 1 second to 60 seconds on a lot of different metrics that are related to load average, CPU utilization, more usage around the disk read writes and how much storage you actually have left. These metrics are all delivered in the CloudWatch, which is our monitoring service, and then you can build alerts based on these metrics. So you can define a threshold as far as at what point do you consider the metric to maybe be going bad, or you might want to know more about it. And these alerts can actually then notify you, or you can construct the notification to actually take action on your database or your application, depending on what that particular threshold is and what that particular metric is. I mentioned you can view these in CloudWatch or in the AWS or in the RDS console, but you can also extract this information using our APIs to be able to actually visualize these metrics in your own tool, or even be able to pump them into a third-party tool that you might prefer to use to be able to look at all your metrics related to your database and your other applications. This is just a quick example of a dashboard that was custom created to be able to give key details about a particular database, so things around CPU performance, storage, memory, and the write IOPS. This is just kind of showing you that you have the ability, once you have all these metrics, to create your own dashboard that makes the most sense for you as far as being able to analyze your database. And I mentioned the third-party integration before, so there's lots of different AWS partners out there that can take in your metrics and have support for being able to take and display your database metrics through their visualization technologies and allow you to maybe even combine the database stats with other stats related to your applications that you're running for your business. So migrating to Aurora, there were some in the polls earlier, there were some databases that were MySQL, but also some that weren't MySQL. So there's some questions around how do I actually start using Aurora? And so certainly you could do some do-it-yourself stuff, just simply extract the data through a SQL query and write it into another database. But there's some other maybe a little bit simpler or a little bit clean options that do exist for you that you might want to think about using. The first one is something that's new that's come out, is actually allowing you to take a MySQL backup, put it into S3, and then create it and turn it into an Aurora database. So this works for anybody who you have to use the Percona extra backup product or tool to actually create that backup of your source MySQL database. You then take that backup file, put it into S3, and then you can actually create a brand new Aurora cluster and use that S3 location as the target information to be able to take that backup file and turn it into an Aurora database. So one possible option if you're running on MySQL as far as how to be able to take that existing database and turn it into an Aurora database. Another option that exists out there as well is the AWS Database Migration Service, and this is really here to help you cover a lot of different use cases as far as migrating from one database to another database, whether they be the same engine or even different database engines. And so this service allows you to actually be able to keep your applications up and running and be able to copy data from one database to another and then actually continue to replicate that data from one database to another. All it needs is a source and a target database, and it needs to know which engine each of the databases are running. And then it can actually replicate that data. It could be running from your own data center into an RDS database instance. It could be running a database on EC2. It's really a little bit independent of that platform and really more focused on the database engine. So how does that work? So the first thing is that you're going to have your users and you've got them connecting to your database. You're going to start a replication instance running in AWS. You're going to connect the migration service to your source and your target databases. You're going to choose which tables and schemas or databases you actually want to migrate. And then you're going to let the database migration service actually create the tables and load all that data and then keep them in sync between your source database and your final target database. Once you're comfortable with everything and you've done the right amount of testing, you can actually then cut your applications over to be able to point at that new target database that you can start using in AWS. So one of the things I mentioned a few slides ago is that you can actually use the database migration service to migrate from one database engine to another. One of the challenges with that is that each database engine has its own way of doing its data dictionary and how it defines schemas. So things don't necessarily translate one-to-one when you migrate from one database to another. So we have another product called the schema conversion tool that will actually once again take in a source and a target database, and it will actually analyze the schema in the source database. It will automatically do any conversions that it can do to convert it into the necessary data definition in the target database, and then it will actually highlight any changes that it couldn't make where it couldn't find an equivalent conversion for a particular part of your schema, so that you're able to focus your technical and your development efforts on making those particular edits as opposed to having to go through and test and verify everything that may work from one schema to another. So a great way to, if you're looking to go from one database engine that's not MySQL and into Aurora, this tool may be a great benefit for you to kind of help and figure out where you might have gaps that would prevent you from getting into Aurora and where you need to make changes. So overall, through all of this, we kind of feel that Aurora is a perfect fit for enterprises. So it gives you that availability that you need with a database through that 6-way replication of the storage tier across 3 availability zones. You can really achieve failover times in less than 30 seconds, and the crash recovery when a database does crash is near instantaneous. You get the performance and scale that you want out of an enterprise database. You know, we saw those read and write numbers, over 100,000 writes a second, over 500,000 reads a second. The very low latency for read replicas because we are just pushing very small amounts of data across the network. And you can provision up to 64 terabytes of storage to be able to store for particular Aurora clusters, so it can hold and handle a lot of data. And then it's a fully managed service. So when you want a database and you want infrastructure, you're able to get it and start using it right away. The Aurora and the RDS teams take care of all the patching and the software upgrades. We take care of all those backups that can be a challenge for you and offer the ability to actually restore and recover to a point in time. And we take care of scaling the compute and the storage that's related to supporting your database. So when you start comparing features, many of the features that I've talked about are very unique to Aurora. We've built them to support Aurora specifically, but you can do some comparisons to some commercial database engines, such as Oracle. So often, you know, some of the things that you need out of a database like Oracle are only available in the most expensive database editions, the Enterprise Edition. If you want to do failover and replica, you're going to need something like Active Data Guard, which costs more money for each core that you're using. If you want to back up to S3, you can use their Oracle Secure Backup module, but it requires more dollars per channel, and you're paying for the storage there. And if you want encryption, you can use the Oracle Advanced Security, but once again, they license it on per core, so you're paying more money every time you want to take advantage of some of these features that exist in a traditional database engine that's really geared towards the enterprise. So Aurora lets you really kind of get beyond some of those constraints when it comes to licensing and costs and capacity, and be able to do what you need to be able to do to ultimately support your database requirements for your enterprise. So when we go a little bit further when we talk about that, let's take a look at what some of the pricing might look like when it comes to Aurora. So we've worked to make the pricing as simple as possible when it comes to Aurora. So there's no licensing. This is an open source approach when it comes to the actual licensing of your database. There's no lock-in. And you only pay for what you use. So you only pay for the amount of storage that you were actually using, and you only pay for the amount of time that your database instance was actually up and running. On top of that, once you have a good feel for what size database instance you need to be running, you can actually purchase reserved instances, which can, through an upfront payment, even give you more discounts as far as what it costs to be able to run your database engine. Getting up to a 44% discount for a 1-year commitment, or a 63% with a 3-year commitment. So the ability to have a significant change in the pricing as it relates to your database engine is definitely something that Aurora offers you. So we take a look at the cost of ownership of Aurora versus a traditional database engine. This first slide here is an Oracle database running on EC2, running hourly costs. We have the primary database that's got its attached storage. We have the standby database that's also needs the same amount of storage attached to it. And then we're running a couple of read replicas. Those read replicas also need to be sized the same as that primary database, and they also need to have the same independent attached storage tied to the database engine. So overall, when you look at the instance costs, the licensing related to that particular database engine, and the storage costs, you end up at a total cost for this configuration of being able to run costing $89, almost $90 an hour to be able to run this database configuration. When you look at a similar setup when it comes to Aurora, there's, first of all, you can notice that this slide's got a lot less busyness on it. There's no idle standby instance. There's no standby needed because your read replicas are your failover targets. They are your standby databases, but they can also be doing work and acting as the read replica. You have a single shared storage volume, so you don't have all those independent storage layers that you're having to pay for and use. There's no need to provision IOPS and pay for those provisioned IOPS. You pay for IOPS as you use them against the storage layer with Aurora. And so overall, there's a reduction in the I/O that actually happens, as we talked about earlier, because we're not sending as much data across the network. So your amount of IOPS that you need to use goes down as well. So with a similar configuration, at the same size, same amount of storage, same size database nodes, we're able to achieve about a 78% savings, or running at about $19 an hour versus the $89 an hour with the database configuration on the previous slide. So we'll take a few minutes and just kind of focus on some enterprise use cases. I know that we're getting close on time, so I'll breeze through these a little bit. These are case studies that exist on our product pages, and you can dive deeper into these yourself when you need to. Aurora has kind of become our fastest growing service in AWS history. So it's been generally available for a little over a year right now. And this has outpaced all other AWS services as far as how quickly it is growing and being used by our customers. And you can see here it's being used by a wide range of customers, crossing a lot of different businesses and a lot of different industries. One example of that's actually come out recently is Zynga, who does online gaming. They've got a lot of infrastructure. They've got a lot of smart people running and supporting their games, but they had some challenges running traditional relational database technologies at any scale. They were really struggling with the instance recovery time that it took to actually recover when a database instance crashed. They were really having to monitor some pretty mundane jobs, but also very critical, so they were investing a lot of time around that. And then they had a lot of latency that was really existing for the database storage that they were using. So they went to Aurora, and they found they were able to get over 9,000 selects a second during their peak workload for a 150 gigabyte data set. It significantly reduced their operational overhead. They didn't have to deal with all that monitoring of these mundane work, but these critical jobs, because it's handled by the managed service now. And it simplified how they could scale for large-scale events. There's actually an example in their public blog post about how their master database was being overloaded for a period of time, and they were able to create a new read replica in a matter of minutes that was scaled to be larger, and then fail over to that read replica and immediately have their application up and running on that larger database instance and be able to cope with the extra load coming through. Expedia, the online travel company, they were having some challenges. One, with their current SQL Server-based architecture, it was becoming very expensive, and they were actually finding that it was becoming slower as the volume in that database grew. And then the Cassandra and their Solar indexes, they required a lot of memory footprint and a lot of infrastructure to actually be able to support what those database engines were doing, and it was adding a lot of cost. So they went to Aurora, and they immediately found that it was able to give them the scale and the performance that they needed as an enterprise, but at a much lower price point than they had to deal with before with their other architectures. They were actually able to achieve some key metrics of 25,000 inserts a second, by actually going up to a peak of 70,000 a second, 30 milliseconds response time for writes, and 17 milliseconds for reads over a month worth of data. Alfresco, who's a content management company, they needed some sort of database that would actually allow them to scale to the billions of documents that they had without having any degrade their performance of their application or their database. So they went and tested out Aurora. They were actually able to scale to being able to support over 1 billion documents with throughput of over 3 million transactions an hour, which was 10 times faster than the MySQL environment that they were actually running. A couple of other interesting benchmark results. So they were loading 1,000 documents a second with 10 different client nodes feeding data into the Aurora cluster. Even after they passed that billion document limit, their load rate was still staying very consistent. They were getting sub-second times for multiple things as far as opening a library, page results, and actually being able to navigate to a site within their application. The indexes efficiently used over 3.2 terabytes of data. The indexes worked. They were able to still get their data quickly. As they got past that billion documents, they found no indications of any sort of bottlenecks that were related to the size of the data set that they were using. And the load at the CPU level at their database was quite low, 8 to 10%. And their nodes, all those 10 client nodes that were writing data, were only hovering at around the 25 to 30% node. So they were able to achieve a lot with a very large data set and be able to continue to support it as they move past that initial data set. ISCS, which does insurance claims, they've been running a SQL Server and Oracle data warehouse for quite a while, and they were really having some big challenges there. They were having some cost challenges. They were having some maintenance challenges of having to deal with that software and having to constantly put a lot of operational investment into it. Their SLAs were suffering, and they were finding it very difficult to manage any sort of redundancy across multiple locations. So they went in and used Aurora. And some of the things that they found, that the backups of their SQL Server environment, which took 5 to 6 hours a day, now happen continuously on Aurora. Remember we talked earlier where we're constantly just backing that up into S3. So they didn't have to worry about that anymore or worry about the amount of time it took to get their backups. They can actually create a snapshot in 5 minutes to create a new database if they need to. The data that was only available once a day can now be migrated continuously from Aurora into their data warehouse using the read replicas that I talked about earlier. And their performance scale is linear. So they already had optimized their application to be able to generate concurrent requests, lots of concurrent requests. So they're able to take advantage of the concurrency that Aurora likes and loves, so that they can really get the most out of that Aurora cluster and be able to get as much throughput on their application as possible. And then finally, the Earth network. So they process over 25 terabytes of real-time data daily. So they needed some sort of database that was going to allow them to grow and expand with that data analysis. And they were able to use and move to Aurora and achieve the data growth and scalability that they need, moving away from certain SQL Server that they were using previously to support their operations. So learning was one of the key things that we saw on the poll. So if you want to learn more, my first recommendation is go to the Aurora homepage. The URL is right here. You're going to find product reviews. You're going to find white papers. You're going to find guidance for hands-on labs. You're going to find customer references for people to learn more about what is Aurora, how do I get started with Aurora, what kind of benefits can I get from Aurora. I'd recommend going and take a look at this page, use that as your getting started page of diving deeper into Aurora and what it can do. And finally, we're in that season again. reInvent is fast approaching, so registration is currently open for reInvent coming up at the end of November. It's a great event. I know that there'll be a lot of Aurora content that's delivered there and a chance to meet up with other people who are looking at going to Aurora or now running on Aurora and learn more of their experiences around using this database engine. So if you haven't signed up yet, I encourage you to sign up and attend. It's a great learning experience and a great opportunity. So with that, I will first of all thank everybody for their time. I really appreciate you sitting around and listening in on this. I hope it was beneficial to you and that you were able to get some good information out of this.
Thanks a lot, Scott, for a great presentation, and again to Abdul, Rory, and Kwesi for answering your audience's questions. If you have any feedback on previous and upcoming webinars or suggestions on the topics you'd like AWS to cover in future webinars, please drop us a line at aws-webcasts@amazon.com. Again, that's aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. Thanks to the audience for taking the time to join us today, and enjoy the rest of your day.